Today's quick tutorial is going to be on looking at how to calculate significance tests. So I've been provided with a question which is, I have a mean and standard deviation of two different methods. And I've made 11 replicates. So method 1 and method 2. Now this could be HPLC methods, it could be GC. In this case I believe it is spectroscopy, but the principle is always going to be the same. We have our mean, and in this case we've got 0.2972, and method 2's mean is 0.3038. And then we've got some standard deviations. It's very nice when somebody else does your calculations for you. 0.000725. 0.001410. Before we do any sort of mathematics, it's always a good idea to just have a look at the numbers that we've been provided with. In this case, that we can see that the means, and if we were just doing this to 2 decimal places, you would say that this is 0.30 and method 1 is 0.30. So this is where having these extra decimal places is going to be super important, and there is a difference. The question is it significant? So our first question is the difference in the standard deviation between these two methods different at a 95% confidence interval? So standard deviation difference at 95% CI. So the first thing we're going to have to do is we are going to have to perform an F-test, checking to see if our variance is equal. Keeping in mind that the relationship between standard deviation and variance, so standard deviation is the square root of variance. The way we calculate variance, therefore, in this case is nice and simple. So for our method 1, we're going to calculate our first variance, which is just our standard deviation squared. 0.00725 squared equals 5.25625, times 10 to the minus 7. I'm keeping all of my decimal places in for the time being, because as you saw previously, if we start rounding, we might lose the detail that we care about. Let's do the same thing with our second variance, so 0.001110 squared equals 1.301881 times 10 to the minus 6. So that gives us our variances. Next thing we need to do is we need to determine our F statistic. And this is done by calculating the ratio between these two variances. So F equals our S2 squared divided by our S1 squared. So dividing those two variances, and that gives us 1.3018. That's our F statistic. This is going to be important, so we're going to put a box around it so we can find it later. Next thing we're going to do is we need to determine our degrees of freedom. Degrees of freedom is usually just, in this case, n minus 1. So if we have 11 replicates, that's our n. 11 take 1 gives us 10 degrees of freedom. Now, because we have our two methods, because we're comparing is this one greater than this one or this one greater than this one, we have a two-tailed test. What that means is, although in our statistic table we might be thinking actually because it's a 95% confidence interval, we'd be using an alpha of 0.05. Remember, because it's two-tailed, half of our value has to go on one side, half of it has to go on the other side, so we're going to use the alpha parameter for a 0.025. So this is where you're going to have some sort of table provided. You're not going to be able to see this on your screen, I'm very sorry for that. This is just one I photocopied from a book. But the same form is true for all of them. You double check that you have the right alpha value. It's always provided at the top here. And then, because we're doing a two-tailed test, we have our n equals 10, and our other population which equals 10. And I've already highlighted this. We read along and we read down and we find our F critical. In this case, what this says on this little table here is that my F critical is 3.72. So we can just write that down. F critical equals 3.72. Now, we need to compare the calculated F value to the F critical. So let me just find my piece of paper. My calculated F was 0.4768, and we've got F critical here. If F is greater than F critical, it's significant, and if F is less than F critical, it's not. So we've calculated an F value of 2.48, which is less than 3.72. And please remember, write down all these facts. So I need you to say, calculated F is less than F critical, therefore is not significant. And hopefully that gives you a clear guide on how to calculate significance testing for standard deviation.